So, here's your basic problem. It says that the pendulum has a period of 2 pi times the square root of L divided by G. When you enter the two weights of the pendulums that are given, you get the two expressions, 2 pi square root L over 100 for pendulum number 1, and for pendulum number 2, 2 pi square root of L over 200. Now, the additional information you're given is that pendulum 1 has a period that is 4 times as long as pendulum 2. That means that pendulum 2 swings 4 times while pendulum 1 swings only once. That's a key idea. So now we're going to do a little bit of math. The big idea here is that the 2 pi's on the outside are not changing, so we'll just leave them. But this 4 times that I'm putting in front of pendulum number 2, let's go to the square root bit of this business. You may recall that the square root of 16 is what makes 4. So in order to put this 4 into the square root part so that I'm not changing the 2 pi, those are the same, let's just keep them the same because our big idea here is equivalency. So 4 squared is 16. Because I'm putting it into the square root, I want 4 squared. Now 16 divided by 2 is 8. Now in comparison to pendulum number 1, I've got 8 times the length of the pendulum over 100 compared to 1 times the length of the pendulum over 100. Therefore, given all the information that we were given in the problem, this pendulum number 2 is 8 times as long as pendulum number 1 to fit the scenario.